with this. Who has seen to-do MVZ before? A fair bit of people. At least one person has not, so I'm going to explain it. The to-do MVZ is a great framework for explaining technical frameworks, both backend and frontend. And today I'm going to use it to demonstrate my topic. I'm going to talk about Splitterators. Once everyone is comfortable, I see we have a few stairs remaining. I'm going to talk about Splitterators. After that, please rate this session, and then we'll have lunch. Any questions, please approach me afterwards. I'm going to get started. So my name, I'm William Bakker. I'm a software engineer at IMC Trading. That's a small trading company in Amsterdam. And what I'm doing there, I'm working on our Java stack. I'm working on applications with a high amount of clients, easily thousands of them, but also a rather big amount of entries in them. And I would say easily I'm dealing with millions of entries. And I'm dealing with scalability issues. I'm dealing with applications running out of memory or not being able to handle the throughput. And in that light, I started looking into the features that were introduced in Java 8 as of the Streams API. Now, the Streams API was introduced in 8 and wasn't changed really a lot up to 11 to 13 today. So all examples probably can be made, whether it's in 8 or in 13, it's not a lot of difference. But my talk is about Splitterators. So what are Splitterators? Splitterators are the building blocks of streams. So if you're saying I'm going to produce a stream, then effectively you're saying I'm going to produce a Splitterator. And it consists of two parts. It splits, so it can chunk big collections of data, big data sources into smaller bits, and it can iterate over that using a fluent API. Now I'm going to also give you one disclaimer today. I'm not going to split. This is a big topic. I can easily spend 2 more hours talking on all the intricacies when dealing with splitting, dealing with the internals of the fork join pool that's behind it, but that's a big topic. So I'm going to focus on the advantages that the Splitterator interface gives us when iterating over data. And probably it makes a bit more sense if I put a goal in it, because yes, I will use the to-do framework to explain it, but in the end, I will show you one of my production services that's actually using this now. So what I'm commonly dealing with is I need to read an input stream. I'm doing a query on a REST service, and I just get lots and lots of bytes. And my stream represents easily millions of entries. Now, this was made, I would say, my initial presentation here was made about half a year ago. By now, I'm already looking in the tens of millions of entries. That will cost me significant memory pressure if I'm all going to collect that in memory. If every element is only a kilobyte, then having a million of entries, I'm into the gigabytes. And yes, my hardware is cheap these days. You can easily get a box with 64 or even 120 gigs of RAM. But my workstation only fits, well, this one 16, the newest one 32 gigs. So you come to a point where even if it fits in memory, it no longer fits in my workstation. Another side effect, if your application becomes too big, I will have significant garbage collects from time to time. I don't want my services to be paused for 10 or 30 seconds doing a huge garbage collect. And finally, my application is actually able to consume elements one at a time, to do it in a streaming way. So why work in the list paradigm to start with? So I want to show you a bit how I got towards where we are today. How do we get to Java 13 in that sense? Because when I started was with roughly Java 6, and then Java 8 was introduced, and you said like, hey, this is awesome. We now have the Streams API. And, well, let's take you through it. How do you migrate code from a Java 6 to, well, Java today, I would say. So here is my interface that I'm being asked to implement. Given a list of the to-do elements, remember the initial screenshot, please give me all the to-dos that are pending, so the ones that haven't been completed yet. The to-do is quite a simple object. It has a string, a title, it has an order, and it has a status whether it's not completed. So I should be able to implement this quite quickly. So what I do is I instantiate a new array list, I make a for loop to iterate over my values. If my value is not complete, I'm adding it to my result and I'm returning that. Great. So this is code that I could have written years and years ago and would still work today. Along comes Java 8, and we start to refactor it. We say, well, this new API is awesome. We now have this forEach method on my list, and I can give it a lambda, and inside my lambda, I do the same check, and I return it again. Then someone says, well, actually, here's the Streams API. That's way better. Instead of you calling the forEach, you call .stream, and you give it a filter. Inside the filter, you say, well, actually, for every value added, if the or filter everything that's not complete, and then finally collect it into a list. I can actually replace that filter, the contents of it, by a few predicates. I can say, well, I do the method reference on to-do is complete, and as of Java 9, there is even the predicate .not, where you can even make it more fluent. And finally, someone says, well, yeah, you've come so far, we can actually inline it. So all these steps might resemble your day-to-day activities. They may feel familiar. But what did I just do? I spent lots and lots of time on refactoring code that was already working, making it into a new version that's also working. So is it really better? Is my code easier to read? Well, perhaps the body, if you extract your methods properly, if you use method references where possible, perhaps yes. Is my code stateless? Well, would you have to use, for example, a good unit testing framework around it to verify that I'm not altering my collection that I give into this method. What about performance? I used to have a for loop with an if statement in it. Probably much faster than that it won't go. Now I have a streams object. At first I copy the list into a stream, and then I do a filter operation that will also instantiate a few objects. So perhaps I increase my memory pressure a bit along the way. Is it really better? My statement today is yes, the Streams API is better, but only if you identify your requirements correctly. And these requirements can be different from application to application, from team to team, and they broadly go in a few categories. One of the subset of applications that would benefit from the Streams API is to use a fluent API. I want to use stream.filter.map.findFirst. Awesome. That also reflects into you giving something out to your clients, and the clients can easily apply these methods. If you're giving out a custom interface, your clients always have to do a bit of coding to use that interface. Perhaps you want to reduce your memory pressure, and that's not in the case where you start off with a list in memory and then you convert it into a stream because the list is already in memory. But what if the list is not yet in memory? What if, in my case, you get an input stream with bytes? What if I'm able to process bits of bytes and not having to wait for having everything in memory? Some applications could benefit from parallelism, using the parallel method in Stream. Or some applications could really benefit from the short-circuiting behavior. So I'm getting this big stream in, but I'm only caring about the first 10 elements. So there are various requirements, and you have to carefully think is it worth it? Is it worth refactoring to streams? So continuing on my example, what if I don't return a list, but what if I return a stream instead? Now I've stopped telling the client that he has to operate on a list. I said, well, here's a stream, and if you like, you can collect it into a list. You may also collect it into a set, or do anything else. I'm no longer telling you what you're getting. And finally, perhaps my method shouldn't consume even a list or a collection. I'm saying perhaps it should consume a stream. And at this point, I got so far that you could consider, well, why don't you just inline this all together? So, indeed, here are the two examples. The old client could still collect it in a list, but another client could say, well, actually, I just want to have the first one. I don't care about the rest. Now, as a warm-up, I want you to think of the following. Suppose I have 3 of these to-do elements. Number 1, 2, and 3. The first is completed, and the second 2 are non-completed. The last 2 are still pending. Now, what if you see this? Given you execute my new pending method, and I'm limiting to 2 elements, I'm extracting the title, and then after extracting the title, I'm going to quickly print it, and then I'm going to take the first. What do you think will happen? Will you just get title 2? Or will you get title 2 and title 3? Can I see some hands for title 2? It's about a third. And, oh, sorry, I went too fast. But that third is right. Why? I'm just showing this example to make sure that you really need to think about what's happening here. When you're getting the stream of pending elements, you're only getting number 2 and 3 anyway. Then I'm limiting to 2 elements, which I already had. Then I'm mapping the title, so I get title 2 and 3. Then I'm peeking, so it first prints title 2. And then I'm calling find first. But I have the first already, so now it stops and it no longer prints title 3. All I'm saying here is quite powerful, but you need to be very careful that you know what you're doing. So, the previous chapter also highlights that a lot of people are thinking in terms of consuming streams. I've got a list, and I convert this list in a stream, and I'm doing fun stuff with it. But what if you want to produce it in the end? And I did quite a lot of searching and had quite a lot of problems finding, best practices, finding examples. So what I like to do today is to go over what it takes to produce a stream, what it takes to create a Spliterator. Because once we have produced our Spliterator, we have actually produced our stream. So, the Spliterator interface, it only has 4 methods. And yes, it ships with a few other default methods. But to get a working example, to get a minimum viable product, all we need to is to implement these 4 methods. And even with these 4 methods, only the tryAdvance is the one that really stands out. That said, if I implement the rest, I can benefit from the full features of the Spliterator. If I don't implement the rest, I could just as well implement an Iterator. So, tryAdvance, the first method. tryAdvance is the core of your Spliterator. What it does is, if there is a next element, perform an action on it, and then return true. Always return true. Any other case, you return false. That's it, nothing else. And I had a hard time sticking to this interface. I can actually look back in my first few implementations, and I returned, I returned false if there was no further element, but I already processed one. No, stick to the interface. If there is an element, perform the action, return true, otherwise false. Later on I can show a few examples what can go wrong if you don't. And then the Java doc already starts mentioning a bit about characteristics. There are many characteristics, I'll get to those later. This one mentions about a Spliterator can be characterized as ordered. And that basically means that your actions are evaluated in encounter order. Doesn't give us much, but let's keep it in our mind when dealing with characteristics in a second. Now, for practical use cases, if you just want to have a stream, but you don't care for anything else around it, we can actually stop here. Actually, there is a utility method in the class called Spliterators, and that allows you to create a Spliterator even from an Iterator, or from a list, or from various items. So, for the minimum iteration, how to plug it in, this way you can create a Spliterator, and then later on you can refactor on. But yeah, I want to do more. So I'm going to go to the next methods. Trysplit. Trysplit is the core of the parallelism in Spliterator. So what I'm going to do is I'm going to return another Spliterator that contains elements not covered by the Spliterator. So basically I'm chunking up my collection. If I have a source, say I've got a list of 20 elements, trysplit basically is going to return one Spliterator that covers 10 elements, and it moves on my cursor that I will process the other 10 elements. And then the stream API can put it in, well, in a thread pool, and magic happens. Here again, there is a mention of being ordered. Being ordered here is very important. Because if you're going to split, you need to split correctly. And the contract states that if you're going to split, you need to split off a prefix. If you don't, then what's actually going to happen is the result will be reversed. So, but it depends. I mean, perhaps you don't care about order. Perhaps you're going to collect it in a set anyway. But it's important to understand the implications here. Finally, if there's no more use in splitting, your chunks have become small enough to be processed by a single thread, you just return null. You indicate to the JVM, this is good enough, we're not going to split, please execute whatever actions you need to do on my chunk. In practice, today I'm going to talk about sequential streams. So I'm also always going to return null. Estimate size is my third method. Estimate size returns a size estimate of the amount of elements we are going to encounter in the stream. And why an estimate? Well, it may not always be easy to get an exact number. You may have a tree that's imbalanced. You may be very able to estimate the size of the tree, but calculating it exactly would be difficult. And there are other cases. It may be time-consuming to compute. But in my case, given I'm going to be sequential, oh, I've got another hint. If I don't know the size, too difficult to compute, you can return long max value. Just saying, well, we don't know. In my case, because I'm going to implement a sequential Spliterator, I'm going to return that estimate, that size estimate of max value straight away. There is no need on estimating a size of your data source if you're not going to split it anyway. Finally, the characteristics. Characteristics return us a set of characteristics of the Spliterator and its elements. And there are 8 of them. And here I can become a dictionary. Really, each of these items has implications on how the JVM will deal with this stream. And some of them are mutually exclusive. You cannot be sized and concurrent. Size means that you know the exact size, whereas concurrent means that the underlying source could be structurally changed while you're iterating over it. The key thing here is that we are only to report the characteristics that we can guarantee. For example, if we know for sure that all our elements are non-null, we can signify that. But if there is only the slightest chance that one is not non-null, then we should just not signify it. And for all of these, I recommend just to look up on the Java docs, but also on Stack Overflow, to see the implications and the details of it. It would get very boring if I would go in depth on all of these. One thing to note, and this thing I did check in Java 11, and I likely still the same in Java 13, is that the JDK doesn't even use some of these characteristics. So concurrent, immutable, and non-null currently are just placeholders that are not even being used. However, it could be that someone, if you build a Spliterator, that someone inherits from your Spliterator and does make assumptions based on your characteristics. So again, only signify what you can guarantee, and if that's nothing, then you signal nothing. Now, a couple of times I went over the implications, and probably it's more fun if we're actually going to see, well, hey, what can possibly go wrong? What can possibly go wrong if I say something, if I say this Spliterator is distinct while it's not? And let's just get started with it. So suppose I have a stream. So my stream is built up of Spliterator, and the Spliterator encounters in its tryAdvance method the values 1, 1, and 2. Moreover, it signifies that it is distinct. Obviously, it's not. We encounter 1 and 1 twice. So if this is my stream, and now I'm going to call distinct on this stream, what is going to happen? What values am I going to encounter if I iterate over this stream? Will I get 1 and 2? Or will I get 1, 1 and 2? Can I see some hands for 1 and 2? It's roughly half. And how many people think 1, 1 and 2? That's also the other half. Nice. So we have here the optimists that think that everything will be fine, and we have here the realists that say, well, hey, someone built it and it must be broken. It's horribly broken. What's happening here is if you signal that your stream is distinct, but it isn't, and you call distinct on it, then the JVM is actually going to look at it and say, well, hey, it's already distinct, this is a no-op, I'm going to skip this. So you're going to iterate and you're going to find 1, 1, and 2. So don't signal it's distinct if you don't know if it's distinct. But it gets even worse. One of the characteristics is that it can be sorted. And here I found myself with a stream, and it encounters 2, 1, and 3. That's obviously not sorted, but my stream flags it is. Now, I'm going to give this one away, because this is horribly broken as well. If you don't know it's sorted, don't say it's sorted. The JVM will actually look at it again and say, well, hey, this is already sorted by the natural order. You're calling to sort it again on the natural order. I'm not going to do anything. I'm going to straight away return the source. And you get 2, 1, and 3. But sorting is about more than just the natural order. You can actually plug in a comparator. And I'm actually going to do something very corner casey. I'm going to plug in the natural order comparator. Now, what's going to happen now? I have a stream that indicates it's sorted by the natural order, and then I'm going to sort it by the natural order. Will we get 1, 2, and 3, or we'll get 2, 1, and 3? Can I see some hands for the 1, 2, and 3? Quite a lot of optimists in the room. And can I have hands for the 2, 1, and 3? So, surprise, we just sorted our stream. What happened here is that the JVM doesn't actually check that the comparator is the natural comparator. It just says you are going to compare it by some comparator. I'm just going to wrap it always. And I feel this is kind of a bug in the JVM. But it gets even worse. If we plug in a comparator, then we can take out that comparator again. So I still got my stream that encounters 2, 1, and 3. That signals it's sorted. And now I'm going to sort it on the natural order. Then I'm going to access the Spliterator from the stream, and I'm going to ask, what is your comparator? Now, before I show the answers, I need to explain you a bit of Javadoc here, because the Javadoc says, if the stream is sorted by a comparator, it returns that comparator. So that would be the natural order. If it's sorted by the natural order, it returns null. Or, if the stream is not sorted, it throws an illegal state exception. Can I see some hands for the natural order? About 20%. Who thinks we'll get null? Fair chunk. And finally, who thinks it will go horribly wrong? A bit. And many people just have no idea. That's actually a very good thing at this point. You have no idea. An illegal state exception is thrown. I wrote this in 8, and I got really flabbergasted by it, and I did it in 9, and I did it in 13, and it's still broken. If you construct something with a comparator and you call getComparator, you get an exception. Any. So the idea is that the Javadoc say that if you implement your Spliterator, you are to, you can override the getComparator, that's a default method, but the JDK itself actually doesn't. So, building a Spliterator and building a stream, it takes a while. I work with a couple of colleagues. Some of my colleagues have been working 10+ years with Java, and I showed them like, hey guys, I want to explore this domain. I want to produce a Spliterator. Can you please review my code? And I sent my first merge request, and they looked at it and they said, oh, this is awesome. This will be so much better. We added tests and we put it in production, and it horribly broke. So we went back to the drawing board, found the corner case, again, invited other colleagues. They all said, oh, this is awesome. And again, we found the corner case. All I'm saying here is it's quite, it was quite a road to get here. I'm going to implement tryAdvance, just that we can see, well, how can we get here? The core of tryAdvance, remember, if there is a next element, operate on that element and return true, otherwise return false. If we implement it like this, with the iterator inside, it's already a very good start. But we can do more. Unlike a list which is already in memory, or unlike the iterator, where, for example, if you need to get things out of a database, you need to open the database connection and then start iterating, I can make a decision to do late binding. So when I construct my Spliterator, when I construct my stream, I don't know if people will be iterating over it. So people can just construct the instance, but what I can do is inside my tryAdvance, I can actually decide to open, for example, a connection to a database, or to start reading a very large file. This comes at the cost of the time consumed at the first iteration, but comes at the benefit that we may not get here in the first place. So whenever you deal with especially I/O, consider to add late binding into your tryAdvance. All the other methods I can get away by the most simple approaches. I'm not going to split. I'm going to return null straight away. I'm not even going to estimate my size, even if I know it. I'm going to return max value straight away. And by the way, take care that you return long.maxValue and not integer.maxValue. I also tried returning 0 in estimatesize. That causes some short-circuiting underwater, but has no guarantees for the future. So the Java doc actually doesn't mention anything about it. So I can avoid a few method calls by returning 0 here, but actually for safety I should just return long.maxValue here. And for my characteristics, I'm just returning a 0. The characteristics is an integer that consists of all the bit flags. I could say, well, I know for sure it's not null or whatever, but this is the minimum working example of getting your Spliterator done. And finally, you wrap it in a stream. Here is an example. There is a class called stream support, which takes a Spliterator and it takes a Boolean, whether it's not parallel or it's sequential. And that's all. But only if it were so simple. I get into I/O. Obviously, I always have to deal with databases, and as mentioned, my database have many rows. And I'm going to read from them, and things will throw exceptions. I'm going to read from files, and they will throw I/O exceptions. Now, what am I going to do? So, dealing with I/O, we add a chapter to our Spliterator. First and foremost, if I have an I/O bound stream, I must always make sure to close my I/O when I'm done. If I don't, I may run out of open database connections. I may run out of open file pointers on my file system. Moreover, stream actually is auto-closable, so that's great. So I can wrap it in a try with resources black, and it will close my stream once I'm done with my stream. But the Spliterator is not. So, arguably, should the Spliterator be? Isn't that bit of well, should you follow the single responsibility principle? Should be managing the I/O be dealt with separately? But pragmatically, these are two tightly coupled pieces of logic that I like to combine in my Spliterator. So I need to make sure that I close my Spliterator as well. So here is my previous example. I implemented my tryAdvance. I added my late binding check. If there's next element, I operate on that element, I return true, otherwise I return false. I'm going to add two steps here. First, if there is no next element, before returning false, I'm going to close my source. And inside my close, I will make sure that I will handle exceptions. But this may be a very well statement. Even the client may still do stuff on the stream. If there's no remaining element, I can close the source and then return false. Also, remember the Spliterator and the stream are stateful. If you take a list and you say list.stream and you're going to iterate over it, you can only iterate over it once. The second time it will throw an exception, something along the lines of this stream has already been consumed or operated upon. So we should do the same thing. We should make very bold statement that before trying to do anything, if we're already closed, stop. This is a programming bug. This is a client trying to iterate over my collection twice. So let's not get into any fake runtime exceptions later. Let's throw a bold, well, illegal state exception. My source has already been closed. So let's check if you have paid attention. Given a stream, and it will print open on initialization, I'm going to encounter my favorite 1, 2, and 3 again, and I'm going to print close when I'm closing the stream. Now here I've got my example. I've got my stream, and I limit to 3 values. And then for every element, I'm going to print it. I'm going to wrap it in a try-with-resources block. That means that when I exit this block, I'm going to call the close method, because stream is auto-closable. What will happen? Will I see open 1, 2, and 3 and close? Or did I actually not close my stream? Who thinks we closed our stream? Spliterator. Yeah. And who thinks it wasn't closed? A fair bit. Again, lots of people probably are quite right with, I have no idea. It's actually not closed. So remember, what happened here is I encounter 3 elements, 1, 2, and 3. And I'm limiting myself to 3 elements, which is also great, because I encounter 1, 2, and 3. In my tryAdvance, I can pull it back up. I start at the top. I'm ensuring not closed. If there is a next element, I'm going to accept it and return true. That happens 3 times. And then I've reached my limit operation. So if I wouldn't have had my limit, it would get in here the 4th time. It would see there is no next element. It would close my data source, and it would return false. But because of my short-circuiting limit operator, I only got here 3 times. I never got into closing this. Now the try-with-resources block actually tried to close my stream, but that's all it did. It never closed my Spliterator. So we need to add more to it. So here I have the example where I wrap my Spliterator into a stream using stream support. You give it a flag as parallel. I always say false. And finally the client collects it into a list. So first and foremost, the client is going to wrap it in the try-with-resources block to make sure that the Spliterator is that the stream is closed. But then we need to install a close handler on the stream that we actually close our Spliterator. Now remember, the Spliterator is not auto-closable, so either way your Spliterator will be explicitly typed to another class, or you will have direct reference here. But this is the key thing. Your stream is closed, but we also need to make sure that when the stream is closing, that the stream will actually call Spliterator.close in my example. Then we get to the following problem. The onClose takes a close handler, which is just basically a consumer, but it doesn't throw any checked exceptions. Now, when dealing with I/O, everything throws an IOException, which is a checked exception. So in Java 8, they added another exception, which is the unchecked IOException. And the general contract is that whenever you encounter an IOException in your streams domain, you just wrap it in there. But don't forget to add a message. Remember that illegal state exception that was thrown if you try to get comparators, whatever. That's a classical example where the JDK just throws an exception and adds no message. You just get something went wrong, stack trace. When you're in control here, at least tell them what went wrong. I failed to close my input stream, or I failed to close my database connection. And then you still propagate it as a runtime exception, but at least your client will have a bit more information what went wrong. So I'm a Java engineer, And being a Java engineer, I'm lazy. Whenever I encounter a load problem, I'm doubling my heap. But as mentioned, there are limits to it. My workstation does 16 gigs, so in order to load a heap dump on my workstation, I can't go much further. And yes, I can upgrade my workstation. But that's not what I wanted to do. So, given my example, given I have to load millions of entries, and what I'm going to do, I'm actually just going to write them to a file. I've got a stateful service that has millions of entries, and for audit purposes, I just need to have long-term persistence, a simple file, dump to an FTP, great. But it's lots and lots of data. Now I also know my application will be scaling up in the near future. It has already since I built this presentation. So how can I do that without increasing my memory consumption, without getting an out-of-memory exception or error? This is how my client used to look like before. We had a simple view, and our view contained a select. And the select returned a list of elements, the list with 1 million entries. So my client asked my server, can I please get the data? The server said, hey, wait a second, here you have 1 million entries. I all load them in memory, and then I'm going to write them to file. Along comes the stream. Now asking a different question to the server. Can you stream me the data? Can you give it to me? And I will start consuming it one by one. And the most surprising thing, so here I am 25 merge requests down the line. I have made many lines of code in our repositories. But our client had to change 5 characters. Our client only switched from select to stream. And that was a bit of an anticlimax. How simple it was for the client. The client never realized how much work was on our end. Here's the memory consumption of my client before. On the top end, you see my heap size. And what you see, the client starts up, and midway the graph is roughly 1 minute. By 1 minute, I have fully consumed my heap. On the bottom part, you see my garbage collection activity, and it's spiking. Why is it spiking? I'm loading multiple entities. Every one of those entities loads about 1 million in memory, writes it to the file, and then garbage collects again. So these were, one, time-consuming garbage collects, but also what you see at some point, the garbage collector is just consuming 100% of user time. And not long after this analysis, it just failed with an out-of-memory error. Along comes the stream, and suddenly this happens. My heap use is actually it's wobbly, but it's stable. And my garbage collector, well, it has a bit of warm-up in the beginning, but my garbage collector is spending a constant amount of user time on doing small incremental collects. Also, now the vertical axis doesn't go to 100% anymore. It went to only 20%. So actually, the garbage collector is spending 1 or 2% here of time. And then another thing happened. So my previous example, I run my dataset with 3 gigs of heap to make sure I got a out-of-memory error quickly, and it still fit on my workstation. Now I realized, well, hey, what happens if I decrease the heap? So I went from 3 gigs to 2.5, then I got a bit more bold to 2, to 1.5, to 1, and we're going to 512, and I finally was able to run it with 250 megs of heap. It has been quite a long time since I've run an application with such a small heap. So this took a while to get here, and things went wrong. We had some bugs that we caught in various stages of our pipeline. But the core lessons learned from it is always unit test, unit test, unit test, unit test. But not just your Spliterator, but also the stream as a whole. And not just testing that you can say stream.collectToList contains all the values, but actually, what if I say stream.limit5, and then is my I/O closed? Or what happens if, well, in the concurrent example, you can think of many more tests to do. This is quite important. Now, there is a library called Assert, and it has support for fluent assertions on streams. So basically, it hides away lots of the verbosity, and you basically can say, assert that a stream dot contains only the following elements. It takes away the statefulness, so you can say, assert that the stream contains only 213 and do other stuff. If you were to test that manually, you would get an exception saying this stream has already been consumed on. So the Assert library gave me a great starting point to test splitterators, or to test streams, but not to test splitterators. So about 2 months ago, I made a merge request in Assert to add support for splitterators. Now this guy got released 3 days ago. That's sheer luck. In version 3.14, we now have splitterator support for, or Assert and now splitterator support. And what we can say, assert that my splitterator has the following characteristics. It must be sized and it must be subsized. And you can say, assert that it only has the following characteristics. And yes, you can do it with JUnit, but given that the characteristics are bit flags represented in an integer, with JUnit it will say, well, I expected my characteristics to be in 16,444 and I got 12. Great. If you use Assert, it will actually say, I expect it to be sized and subsized, but I found sorted. And in the end, this helped me being a bit more effective in iterating on my changes. Another thing is read. Now, these are probably 2 books that many people have seen, and they spend each about 1 paragraph on this topic. Josh Bloch mentions in Effective Java to not run into this. If you have a client that has a list in memory, then don't force that client to consume a stream to collect it back to a list again. So don't take away all the methods that operated on collections or lists. You can put your stream next to it, but don't go too fast here. Whereas Gabriel Urma in Modern Action in Java actually has a few pages where he explains in more depth the behavior of the splitting, which I didn't cover today. So both books have a great starting point if you want to implement splitterators. So I hope today I've given you a bit of understanding how streams work under the hood and what are the implications of defining how your stream works, what are the implications of setting those characteristics, what can possibly go wrong. And perhaps this will help you producing a splitterator, perhaps it will help you knowing more when to use streams and when not to use streams. So thank you for attending today. I'll be downstairs for any questions, and I hope you have a great day.